Today we're building a complete distributed task queue system in Java with Maven. This is the same architecture used by Celery and Sidekick, background workers processing jobs from a message broker. We'll create 17 classes across 8 packages, a priority message broker, a worker pool with retry logic, a task scheduler for recurring jobs, a REST API for monitoring, file-based persistence, and custom task implementations. Let's walk through every piece in the order we built it. We start with pom.xml. The project uses Java 17, the JSON library for JSON serialization, and the Maven compiler and exec plugins. We define our group as com.taskqueue and artifact as taskqueue. The source files live under com.taskqueue organized into subpackages, core for fundamental types, broker for message queuing, worker for job execution, scheduler for cron-like triggers, API for HTTP endpoints, model for configuration objects, persistence for storage, and util for helper classes. This structure keeps concerns separated and makes the system extensible. The first source file is taskstatus.java. It defines 6 states a task can be in: pending when it's waiting in the queue, running while a worker is processing it, completed after successful execution, failed when all retries are exhausted, retrying during the backoff period before another attempt, and cancelled if the system explicitly stops it. This enum is used throughout the entire codebase to track task lifecycle. Task exception extends exception and adds a retryable Boolean flag. When a task throws this exception, the worker checks if it's retryable. If so, the task is requeued with a delay. If not, the task is marked as failed immediately. This allows task implementations to signal whether a failure is transient, like a network timeout, or permanent, like invalid input. Task result is an immutable value object that captures the outcome of a task execution. It stores the task ID, final status, optional output on success, optional error message on failure, timestamps for when execution started and completed, and the attempt number. This is used by the API to report task history and by the worker pool to track completed jobs. Task is the abstract base that every concrete task must extend. It generates a UUID as the task ID, stores a name and parameter map, tracks its current status with timestamps, and maintains a retry counter with a configurable maximum. The abstract execute method takes a context map, shared state across tasks, and returns an object. Subclasses implement the actual work. The canRetry method checks if the retry count hasn't exceeded the maximum. Priority defines 4 levels: low, normal, high, and critical, each with an integer value. These values are used by the priority queue in the broker to order tasks. Higher priority tasks are dequeued first, regardless of insertion order. Task definition is a configuration object used to enqueue a task. It specifies the task name, matching a registered task type, the parameters map, a priority level, an optional scheduled time for delayed execution, and a maximum retry count. It also has a builder pattern for fluent construction. This separates the what to run from the how to run it, which is handled by the worker. The message broker interface defines the contract for any message queue implementation. It can enqueue a task definition, creating the task internally, or a pre-created task, dequeue a task, blocking for up to 5 seconds, acknowledge a completed task, reject a failed task with a reason, get the pending count, and list pending tasks. This interface allows swapping implementations, for example, replacing the in-memory broker with a Redis or RabbitMQ version without changing any other code. In-memory broker implements the interface using Java's priority blocking queue. It wraps tasks in a task wrapper that compares by priority first, then by timestamp for FIFO ordering within the same priority. Task creation is handled via factory functions registered by name. This avoids reflection and module system access issues. The enqueue method stores the task in a map and offers it to the queue. Dequeue polls with a timeout. Acknowledge marks the task as completed. Reject requeues the task if it can retry, or marks it as failed. The worker class implements runnable. Each worker has a unique ID, a reference to the broker, a running flag, a context map shared across all tasks processed by this worker, a synchronized list of completed task result objects, and a retry policy for calculating backoff delays. The run method loops while the flag is set, dequeuing tasks from the broker. When a task arrives, process task sets its status to running, calls execute, and records the result. On failure, Handle failure checks if the task is retryable and requeues it after a calculated delay, or marks it as failed. The worker prints colored log messages to show what it's doing. Worker pool manages a fixed number of worker instances. The constructor creates the workers in a fixed thread pool. Start submits all workers to the executor. Stop signals each worker to stop, shuts down the executor, and waits up to 10 seconds for tasks to finish. Get all results aggregates completed task results from all workers. This is the main entry point for managing concurrent task execution. Task Scheduler uses a scheduled executor service to enqueue tasks on a recurring schedule. The schedule recurring method takes a task name, parameters, an initial delay, a period, and a time unit. It wraps the parameters into a task definition and then queues it via the broker. This is how periodic jobs like generate a health check report every 15 seconds are implemented. The scheduler runs independently of the worker pool. It only produces tasks, it doesn't consume them. API server uses Java's built-in HTTP server, from com.sun.net.server, to expose HTTP endpoints. The constructor attempts to bind to the configured port, retrying with increment port numbers if the port is busy. This prevents crashes when restarting the application. It creates contexts for/API/tasks and /API/health, delegating to task controller. The server runs on a fixed thread pool of 4 threads. This embedded HTTP server requires no external dependencies. Task controller handles HTTP requests. The handle tasks method returns a JSON list of pending tasks on GET, and accepts a task definition JSON body on post to enqueue a new task. The handle health method returns a JSON status object with the pending task count. Both methods use JSON for JSON serialization and set appropriate content type headers. This provides a simple REST API for monitoring and submitting tasks. The task repository interface defines save, find by ID, find all, and clear methods. File task repository implements this by writing each task as a JSON file in a configured directory. When a task is saved, its file is named with the task ID and contains the serialized task object. This provides basic durability. If the system crashes, tasks can be reloaded from disk. For a production system, this would be replaced with a database implementation. Retry policy encapsulates the retry configuration, maximum retries, initial delay, maximum delay, and a backoff multiplier. The getDelayEms method calculates exponential backoff, delay equals initial delay times backoff multiplier attempt, capped at max delay. The default policy allows 3 retries starting at 1 second with a 2 times multiplier up to 60 seconds. Serialization util wraps JSON with pretty printing enabled, providing static to JSON and from JSON methods used by the API and persistence layers. We create 3 concrete task implementations. Email task simulates sending an email by extracting the to and subject parameters, printing a message, sleeping for 500 milliseconds, and returning a success string. Report task generates a report by extracting the type parameter, sleeping for 1 second, and returning a confirmation. Failing task always throws a retryable task exception. This is used to demonstrate the retry mechanism in action. Each task extends task and provides the public constructor required by the factory. The main method ties everything together. It creates the broker, registers the 3 task types with factory functions, starts a worker pool of 4 threads, starts the API server, creates a scheduler with a recurring health check report every 15 seconds, and enqueues 4 immediate tasks, 2 emails, 1 high priority, 1 normal, a failing task with 2 retries, and a monthly report. The application then blocks on system.in.read, waiting for the user to press enter. When that happens, it stops the scheduler, the API server, and the worker pool, then prints the total number of completed tasks. The shutdown is graceful, workers finish their current task before stopping. We've built a complete distributed task queue system with priority queuing, concurrent workers, exponential backoff retries, recurring scheduling, a REST API, and file-based persistence, all in pure Java with just one external library for JSON. This architecture is the foundation of background job processing in millions of production applications. You can now extend it with database storage, Redis or RabbitMQ brokers, monitoring dashboards, or even distribute workers across multiple machines. The core concepts, decoupled producers and consumers, idempotent task execution, and graceful degradation, are yours to apply in any system you build.